Hello and welcome to this talk about interactive methods for image registration with applications in repeat photography. My name is Axel Schaffland and I'm currently a PhD student here at the University of Osnabrück in Germany, and this project was done together with three Bui, Oliver Vornberger and Gunther Heidemann. So what will this talk be about? First, I will talk a little bit about repeat photography, then I will move on and present to you the re.photos project, our project for repeat photography. Then I will present two image registration methods for repeat photography, and in the end I will give you a preview of our live image registration methods which are currently under development. So let's dive right in and have a look at repeat photography. Repeat photography is defined as rephotographing the same scene from the same vantage point or camera point at different points in time. So in this example we see here the Eiffel Tower during construction, and in the contemporary image here on the right side we see the tower completed as it's present today. Why do we do this? We have different usages of repeat photography. The origin is in the geosciences and in ecology, where you want to examine a landscape change, and an example compilation is shown here, where you have a historic image showing this glacier here, and in the contemporary image you see that this glacier melted away nearly completely. For scale you can see this small figure here which is standing, so this is a person standing on this glacier to give you a sense of scale. So this is the original, or one of the origins for repeat photography, but over time there are many more applications, or are new applications in art, in education, in popular science. You have books about many towns showing historic and contemporary photographs, and so on and so forth. And our idea was then that we provide a web portal to collect repeat photographs and allow average users to register these photographs, to upload them, and allow also for searching and retrieval and so on of repeat photographs. Let me quickly show this to you. This is our web portal. We have the link and the URL here, and you are greeted with this compilation of an historic and contemporary image. You can then move on and browse some more compilations. As you can see here, these are the newest ones, and you have several options to sort. I zoomed already in on this map to Paris. You can see different repeat photographic compilations marked here, and then we can select one, open it, and see again this compilation with a slider in the middle, and also some additional information below, and the possibility to move on to images around this area. So this is our web portal, but before we can have a look at these images or present them in this way, these images need to be registered. What does image registration mean? Image registration means that we want to align two images such that the same objects are located at the same pixel locations in the old image as well as in the new image. This is classically based on image intensity or features if you use an automatic approach. And you can further divide these into rigid transformations, where you have a transformation matrix which is applied globally to the complete image, and non-rigid warping, where you have local adaptations which are pixel-wise and change the pixel location relative to each other. And this allows for more fine-grained and finer adjustments, but can introduce artifacts like that curved lines become straight or straight lines become curved. And in repeat photography we have several challenges. We are multimodal, so we have different cameras maybe even not cameras but other forms of art, for example paintings, as the historic image. We are multi-temporal, meaning that we have changes in illumination, in weather, in season. We have changing objects. If you think back at the glacier image at the beginning, this glacier was completely gone, so we cannot use that for registering these images. And lastly, we are multi-positional, meaning that the camera positions are not met exactly for various reasons, maybe because the historic image was taken from a building which then collapsed or was demolished, and then we have parallax in our images, meaning that foreground objects like here these cyan rectangles are positioned differently in the historic image here on the left and in the contemporary image here in the middle relative to the background objects, in this case these red rectangles. And this then leads to loss of information, so here we do not know how the red rectangle looks behind this area, and in this contemporary image we do not know how it looks here. So then we have to decide, are we interested in our foreground object, what do we want to register this perfectly, or in our background image object, do we want to register that perfectly? And here on the right we see a try to register both of them, and you can clearly see that this does not work very well. So we thought we need an interactive registration method where the user can decide what she or he wants to register. So let me quickly show the first method. This is also a bit longer developed. So basically the idea is that this is point-based. You click in one image and click in the next image. You have an overlay of these two here, and then can select points in these images, and a registration or transformation is computed to get one image aligned to the next. What is new there, that previously we had only 4 points defining our perspective transformation, and now we have the possibility to add more than 4 points, computing an optimal solution where we try to register all points as perfectly as possible. This is the first method. Our second method I can also show to you is then the mouse movement based method, where we are not adding points directly but by mouse movements. And the idea here is that we want even more interactivity as in the first method, meaning we can grab the image and move it around. So in this case we can move, for example, these points together, and then we can pin these at this location. And now you have to think of a pin. We put this pin to both of these images and they are tucked now there together. And then again I can grab this image, and as you can see it's now pinned at this location, and I can repeat this process again and pin it here, and now I can grab it again, pin it maybe here, and do this again here. So this is our new method where we do have this higher interactivity, and also the advantage that we can just touch the image and move it around and play around this very easily and see directly what is happening. So at the moment we are a bit unsure which is the better method, so if you have any ideas there, I'm very happy if you could give any feedback during our workshop. Okay, then let's move on. Up till now we had only methods where we had the historic and the contemporary image already taken, but of course it would be better if we have if you already try to register the images perfectly during taking the contemporary image. And this is exactly here the idea in our third method, where we have a little browser app, our web app, which we can load in our smartphone, and then have a blend of the historic image and the camera preview. I will try to show you a brief video here. So in this case we just have this teapot and have an alpha blending of this pot and can try to move it around and try to register the camera preview with the old image. We have different methods. We have this alpha blending method there. We have also an edge overlay, which you can see now, where you have the edges of the old image blended over the camera preview. And we have also the third method, which is the checkerboard pattern, where we have a checkerboard consisting of old and new, or old and camera preview. And as you can see, this is quite difficult to use, so we are not completely happy with the results, and there's also research by others which come to similar conclusions. What we also tried is to have some animations in case of the checkerboard here. The checkerboard switches in case of alpha blending, we just switch between the two blends, and the edge, in the case of edges, we just blend in the edges. So these methods work more or less good, but there is definitely room for improving. And we are currently trying to find other methods. So there are methods where you use arrows pointing in the directions and so on. And the problem with these methods is then that you have to compute a transformation before to be able to compute the direction of the arrow. So if you have the camera preview, you have to somehow relate this or register this with the historic image, and this has to be done before you can try to compute the directions of the arrows. So this is basically the thing we are currently working on. Okay, so let's wrap it up. We have our Re.Photos repeat photography portal here. You are kindly invited to visit that and maybe even contribute. And of course I would ask you to have a look at the demos and play around with these demos a little bit, and maybe give some feedback about these in the workshop. And if you have questions, of course you can raise them during the workshop, or also just email me. Also, if you have questions of which you think they need a bit more preparation from my side, you can just send me the email and then I will prepare something for the workshop to explain. Okay, then I would like to thank my collaborators, Hiep, Oliver Vornberger and Gunther Heidemann. And of course I want also to thank you for taking your time and viewing this video, and I hope to see you all on the workshop. Okay, take care and goodbye.